Alright, so this is going to be an attempt at an APCSA review video. This section will cover the very basics of Java within CSA, including things like printing variables, various loops, strings, arrays, you get the point. And so we're going to begin with primitive data types or variables, and the first one that everybody always knows is integers, so int a equal to 5. And in this statement, I've declared an integer variable called a, and I've set it equal to the value of 5. Likewise, I can do the same thing with two other data types known as floats. So float would be that, and floats utilize one decimal place up to like 6 or 7, and a more advanced version of the float would be a double, which can hold up to around 15 decimal places and has a larger range of values which it can contain. All of these data types have different ranges of values. For example, you cannot just hold like infinity in an integer variable. Um, there's also chars, which are one letter, one character sort of things right there. They are not to be confused with strings, which I will mention later. And lastly, we have booleans, which are either true or false. So this can only be true or it can be false, but that's it. It cannot take a number, it cannot take a letter. It can only be those two things. And we can only name variables specific things as well, although you can name it pretty much anything if it starts with letters. So I could call this A, B, C, D, E, F equals 6. I could not call it something beginning with a number, so I could not call this 4 ABC equals 6. That would give me an error because you cannot start any name with a 4 or any number really. You can start it with a dollar sign, however, which I think is weird. That works just fine. Anyways, there's also a very important function known as system.out.println, which will let me print anything I want. For example, if I do this and I run it, it will input 5 or output 5 in the console. Likewise, if I had a variable instead, I could just print that variable and it will not print A, but it will instead print out whatever is assigned A, which is 5. I can also print out Boolean, so if I had a Boolean test equals true, I can print out test, or I can print out just true, which will also work. And that is the print method, not method, function. There's also these things called comments within Java that we can utilize to help us keep track of these things. So for example, I had int a equals 5, int b equals 6, and I don't know, int c equals 7. I can use comments to help me keep track of these things by saying, oh, this assigns 6 to b. And the way we do this is by putting 2 backslashes, which will exclude this, whatever comes afterwards, from anything else. So as we run through this code, the IDE will forget about anything that's after this. So if I had a system.out.println 5, and I also had output on 6, I ran that, I would get a 5 and 6 in the console. But if I commented this out, it would only print out the 6. And commenting out helps you keep note of your code, it helps you to manage your code, and it helps you to basically just run it much more efficiently. Well, not more efficiently, but it can help you run through it yourself more efficiently. There's another way you can comment things out. So for example, if I did system.out.println 5, and let's imagine there's a lot more code in here, I could just do this. And basically from the start, after this, all the way until it finds this, the same thing reversed, it will ignore any code that's in this section. You will see this on the FOQ if you're taking the AP test for CSA, more likely than not. Because anything that's in here, so if I type like, help me please, it would not matter. The whole code would just be ignored within this block of comments. And that's how comments work. The next thing we have is operators. There are a lot of different types of operators within Java. For example, if I did a simple int a equals 5, this right here is an assignment operator. It assigns the value 5 to the variable known as a. However, there are more familiar operators to us, like arithmetic operators. Some arithmetic operators are plus, which is addition, minus, which is subtraction, asterisk, which is multiplication, and division, which is the backslash. And these things obviously do what I just mentioned. This helps you add things, this helps you subtract things, you get the point. There is another one called modulo though, and what modulo does is it gives you the remainder of two things divided by one another. So if I had in A equals 5 and B equals 10, and I did system dot out println B divided by A, I would get 2 because 10 divided by 5 is 2. But if I did B modulo A, I would get 0 because the remainder of 10 divided by 5 is 0. And that's how modulo works. And outside of operators, we also have the math class, and I'll get into classes in probably a future video, a future section. But the math class helps us do a wide variety of things, and most often than not, we'll probably be using .pal. So if I had in A equals 5, if I wanted to square A, or 5 in this case, I would do math.pal A2. And so the parameters here, aka what you're inputting, is 5 and 2. And what it does is it takes 5 to the second power, which is 25. So if I printed that out, system.out.println math.pal, I would get 25. And notice how it's a float because that is just how math.pal works. And likewise, if I want to square root 25, I could just do math.square root 25. And it will give me 5.0, once again returning a float value instead. There's also another very handy thing, but not within the math class, actually within the integer class, which is completely different thing, the integer object. I will go into object-oriented programming much later as well, but I can use integer dot max value to figure out the max value that integer can hold. In this case, it is somewhere around 2 billion. And likewise, I can do min value. This may come in handy if you ever need to know this. But an important thing to note is that if an integer value ever goes under the minimum value or above the maximum value, it instead loops around to the opposite one. So for example, integer min value -1 returns the maximum value as you saw earlier. But if I did max value +1, it returns the minimum value. And that's just important to note, there's no such thing as infinity inside Java. Likewise, you could do this with floats, so I could do float.max value turns the max value float, and I could do the same thing with double. And that is just some important things to work with when you're talking about common variables such as integers. Next thing we'll be talking about is the string, which is not a primitive data type. However, it is an object, but that once again can be discussed much later. To declare a string, you do the same thing as doing a variable, so I can do string A is equal to double quotes, and then anything I want, any text I want. I'm just going to say hello world, for example. And this is a string. Although it follows most of the same procedures, this is usually used to capture text. That's pretty much what you can do, hello world. And so if I did system.out println A, it would print out hello world. Notice how it didn't grab the quotation marks. Anything within the quotation marks is basically what it's holding. The quotation marks simply are there to say that, hey, look, I'm a string. Likewise, we can add strings to one another using concatenation. That's what it's called, concatenation. So if I had string A equals hello, notice how I put the space in there. Space count as something inside Java. So if you have a space within the quotation, it will count. And I did B equals world. I can print out the combination of these two concatenated, so it would be A plus B. And I still print out hello world. I basically added this string to the end of this string, which ended up being hello space the world. And there are also many different things that we can do with strings. For example, we can do a substring method, which is basically a small function for an object type. So it is string A equals hello world, and I want to get the substring of it, or basically a smaller string out of it. I could do a dot substring 1, for example, and it will start at position 1. Everything starts at 0 in Java. So for example, the letter H would be index or position 0, the E would be position 1, and as an object goes on, so this L would be 2, this L would be 3, this O would be 4. And so substring, what it does using this form of it is it grabs the letter at the specified index and then it just keeps going forward. In this case, that was index 1, E, and it just grabs hello world instead of the H, because H is obviously at 0. And that's one important thing we can use. Another thing that we'll probably need to use is a.length. And when you use string.length, it grabs how many characters this string is. For example, you can see here we have 10 letters, hello in the world. We have the exclamation mark, and we have the space. So that is 12 total spaces that we need to use inside hello world. And so the length of the string A is 12. That'll come in handy much. Alright, so the next thing we talk about here is arrays, and there are a lot of different types of ways you can go about using arrays. They're basically lists that contain the variables we mentioned earlier and objects. So if I want to declare an array, I would use the variable type followed by a square bracket. So I would do int square brackets for an int array, I'll call it A, equals a list. So you do a curly bracket, for example, if you know what you're going to put into it. And that is an array list, not array list, an array of 3 ints with the number 0, 1, 2 at position 0, 1, 2 respectively, and those positions are called indexes. So if I want to retrieve this value right here, this 0, I would do system.out, print out len, a index 0 as such. And what it does is it grabs the number at position 0. In this case, it is the number 0. So if I were to run it, it would give me a 0. However, if even this value wasn't 0, so if it was like 100, it would still give me that number, so it'd be 100. And you'll want to note that, like I said, these numbers these positions start at 0. So this is position 0, 1, 2. This is not position 1, 2, 3. Just something important to note. And likewise, we can have a string array. So we can do string A is equal to hello world. And it's the same thing. There's an array of size 2 with hello and world being those two. And likewise, I can grab the position, the index 0 string. And it will return hello. And there are some methods that a lot of people need to know in terms of strings. So, I mean not in terms of strings, in terms of arrays. So, for example, if I want to get the length of this, I could do a.length. Notice how it did use parentheses. String uses parentheses with its length. Arrays do not use the no parentheses. In this case, the length is 2 because there's 2 things, 2 items in this array. Likewise, I can generically do different things for the arrays, but I believe that is the only one we need to talk about right now. The next thing we're going to talk about, however, is going to be loops. So there are many different ways you can loop through things. You can iterate through things. For example, for loop. It's very famous. For in I equals 0, I is less than, say, 5, I plus plus, and then we're going to do something in here. So I'm going to do something. System.out, print ln, something. And we're going to go through this bit by bit. So first we initialize an integer called I, the value of 0. We say the condition would be that as long as I is less than 5. So right now it's 0, so it is less than 5. We're going to add 1 to I every time. And what this is right here is a shorthand operator. A shorthand operator is basically a shortened down version of the existing operator. So for example, instead of us saying I is equal to I plus 1, this I doesn't exist by the way, so I'm just going to do it I equals 0. If us saying I equals I plus 1, or even better, I plus equal 1, both these will do the same thing. They'll add 1 to I and return the new value. We can just say I plus plus, which will obviously just add 1 to it. We can do the same thing by doing I minus minus for the subtraction variant. Some other shorthand operators are I multiply equals to 1, which will multiply it instead equal to the new number, and obviously divide equal and modulo equal. Those are some shorthand operators. In our case, we use I++. And then the code after the loop, so anything in here will run however many times you designate it. And so what this does is, for the sake of easiness, I'm going to print out I every time it runs. So the first time it runs, I is equal to 0, so it runs. I is equal to 1 now, it runs, and then it gets to 4. And so by the time we got to 4, we ran through it 5 times, but now as you can see here, 1, 2, 3, 4, 5. We've iterated it 5 times. Now the next time, we do I++, 4 plus 1 is 5, and now 5 is not less than 5. And since it's not less than 5, we do not run the code. We're out of the loop. And so that means that anytime you want to loop through something, generically, if you set I equals 0, this I is less than should be set to how many times you want to run it. I have set equal to 5, it runs 5 times. There's also another type of loop known as a while loop. And a while loop, if I have it I equals 0, I can say while I is less than 10, system.out, println, I plus plus. And you'll see here that what it does is until this condition is broken out of, we will continue running through it. So obviously I set equal to 0, I'm gonna have it print itself, and I'm gonna have it add 1 to itself. And just keep doing this until it gets to 10. See, by the time it's 9, 9 is still less than 10, so we're good. We're gonna print out 9 there. Then we're gonna add 1 to 9, which is 10. Then it goes back up, and then it says, well, 10 isn't less than 10. So it breaks out of the loop, doesn't do any of this, and that's how a while loop works. Another important loop to know is if you have an array of things. So if I had int A is equal to 1, 2, 3, 3. There's a for each loop, and what a for each loop does is for int num A. I'm just gonna have it a system.out.println num. And what a for each loop does is it requires you to make up a new variant of whatever is contained in the array. In this case, it's integers, so I have a new integer called num. And for every num that's within A, right? So from the 1 to the 3, it prints out that thing in this case. So 1, 2, 3. And the important thing about for each loop is that since you have a new number, right, that you're just setting equal to the values within it, you do not change anything within the actual array. So for example, if I printed out num plus 1, right, I get 2, 3, and 4, right, because that's 1 plus 1, that's 2 plus 1, and that's 3 plus 1. However, the actual array is not changed. So if I were to print out, so to out print ln a index 0, it is still 1, even though the previous one printed out 2. Whereas if I were to do a normal for loop instead, so for int I equals 0, I is less than a dot length, right? Because I want to run through it 3 times, because there's 3 numbers here. So I'm going to set it equal to 3, because that's the length of the array. I plus plus. I got AI, which means that the index of I. And I print that out, that would work. But if I were to do something such as AI plus equal to 1, and then I want to print it out as such, this would change the actual value, whereas in the other case, it did not change the value. And that's the difference between a for loop and a for each loop. Another important thing to note is that in an array, you can So I declare it two ways, although I've been using this way, 0, 0, 0. I can also say int is equal to new using the keyword new, int 10. And for example, I would do this, it would make an array of integers size 10, but all of the numbers within it would be equal to 0. So if I were to change this to 1, just for the sake of simplicity, the output ln, you can see here that at index 0 of A, it's 1. But at position 0 B, it is 0 because I have not declared any actual value for them. So what Java does is Java simply puts a 0 to those numbers. And another important thing though is that since I've declared this of size 10 right here, right, I cannot change this. I cannot add anything to an array. I cannot subtract anything from an array. I can change the values within the array. So for example, I could do b0 equal to 5, and now within this array it is now 5, but I cannot actually change the array itself. Like I can't add any numbers to it, I can't take any values away from it. Another type of array, however, is a two-dimensional array, and by simply putting another square bracket there this time, it's equal to, I'm going to say new int 2 2. And what this does is it essentially creates, do this for simplicity, it essentially creates a grid or an array of arrays. And so in here what we would have is we would have 0 0 0 0, and that is what usually the representation will look like on the CSA test. What this means is it'll have two arrays of size 2 each. So if I want to retrieve the first value in the first array, I would say system.out.println a 0 0. And what that means is that it will have grabbed the first slot in the first array. So if I were to bring this back out again, 0 0, that means that it went to the first array or the first row here and it grabbed the first thing, so the first column. So it would be this 0 right here that it grabbed. Likewise, if I did 1 1 in this case, it will help grab this 0 because it went to the second row right here and it went to the second column right here. So that's how two-dimensional array works, and the last type of array that I'll be discussing will be an array list. And the way you go about declaring an array list is you simply say array list integer in this case, or a string or double. However, an integer is somewhat different from a normal integer, is that it's actually an object. So this is where the integer.maxValue class method comes from. And what Java does is it almost auto boxes. I believe that's what it's called, auto boxes for you. So if you would have just put it on like the AP test or whatever here, you will probably still get the point. But anyways, array list integer a is equal to new array list 10 will probably work. Oh wait, integer. There you go, okay. And sorry, I'm still on that array list, array grind, I guess, but so I've declared an array list integer a is equal to a new array list also of an integer. And this right here, that is where you can most likely put the size, but anyways, what an array list is, it's a dynamic version of an array. So you can add anything to it, you can subtract anything from it. So I can do a.add 10, system.out.println, and the way you grab something from an array list is not the same as an array. You actually use the get method. So I would do a.get 0. And so what this means is I initially declared an array as empty, an empty array list, right? and now I've added 10 to the end, and I realized, and now what that means is the only thing in there is a 10 at position 0, and so by using the get method, I retrieved that 10. Likewise, if I did a dot add 20 after the 10, it's still 10 because it adds to the end of the list, right? So 10, 20. However, if I did this here, oh, sorry, did that wrong, 0, 20. Now it's 20 because another way you can do the add method is you can specify the index where you want to add it. So 0, 20 means at index 0, add the number 20. And so now the new number at position 0 is 20, and the 10 is at position 1 instead. And likewise, I do believe I could just print out the array list right here. It's 2010. However, I did it this way without specifying index, it is 1020, and that is how an array list works. You can also have an array list with strings, and obviously, you want to remove something, you can just do um, a dot add and a dot remove, and this will remove whatever number is at index of 0, or obviously string, or whatever it is you declared your array list to be. And that is a very hastened generic review of the basics of Java so far.